two bodies connected by a string which passes over a fixed pulley and another movable pulley. One body is placed on a horizontal table and other is suspended by the movable pulley. So this is the diagram here. P1 is the movable pulley. P1 is the movable pulley through which a body of mass M1 is suspended, through which a string is passes and a body is suspended by using this pulley. A body of mass M1 is suspended by using this pulley, and P2 is a fixed pulley which is placed at the edge of a horizontal table. P2 is a fixed pulley which is placed at the corner of a horizontal table. A body of mass M2 is placed on this horizontal table, and M1G is the weight of the body of mass M1 which is suspended, and tension. There are two tension P and T are acting in the string to which the body of mass M1 is suspended. The body of mass M1 will be moving downwards with an acceleration A1 equal to A by 2 under the action of the force M1G and 2T, twice of tension. And the body of mass M2 will be moving with an acceleration A2 equal to A under the action of tension T2, tension T. When the body of mass M1 suspended through the movable pulley P1, suspended by the movable pulley P1, movable pulley P1 moves downwards with an acceleration A1 equal A by 2, moves downwards with an acceleration A by 2. With an acceleration A1 equal A by 2, A1 equal A by 2. As the total tension acting in the string in connection with the motion of the body of mass M1 is T, and T plus T means 2T. As the total tension acting in the string to which the body of mass M1 is connected, to which the body of mass M1 is connected is 2T, comma, the other body of mass M2 placed on the horizontal table, the other body of mass M2 placed on the horizontal table, placed on the horizontal table, placed on the horizontal table will be moving in horizontal direction with an acceleration A2 equal A towards the fixed pulley P2. In this case, acceleration of the body of mass M1 is A by 2 and acceleration of the body of mass M2 is A. because tension acting in connection with the motion of the mass m1 is 2t, and tension acting in connection with the motion of the mass m2 is t. Will be moving in horizontal direction with an acceleration a2 equal to a towards the fixed pulley p2, towards the fixed pulley p2. In this case, tension into acceleration equal constant, therefore t1 a1 equal t2 a2. Here t1 equal to t, comma t2 equal t, and a2 equal a. Then putting this value in the previous equation, we get 2t into a1 is equal to t into a. Therefore a1 equal to a by 2. Therefore a1 is equal to a by 2. a1 equal to a by 2. This is not the common acceleration, it is the acceleration of the body of mass m1 which is moving downwards. Acceleration of the body of mass m1 suspended through the movable pulley p1. Suspended through the movable pulley p1. Considering the downward motion of, here the body of mass m2 will be moving with an acceleration a2 equal to a towards the fixed pulley p2. Considering the downward motion of the body of mass m1, downward motion of the body of mass m1, of the body of mass m1, we get m1 a1 is equal to m1g minus 2t. Net downward force acting on the body of mass m1 is m1 a1, means mass into acceleration, and also alternatively net downward force acting on the body of mass m1 is m1g minus t plus t, means m1g minus 2t. Here mass m1 is moving downwards with an acceleration a1 equal to a by 2 under the action of two forces m1g and 2t. T plus t means 2t acts down upwards and m1g acts downwards. So hence net force will be m1 a1, which will be equal to m1g minus 2t. Net downward force is m1 a1 and also it is equal to m1g minus 2t. Or comma m1 a by 2, putting the expression of a1, m1g minus 2t, or comma t equal, or comma 2t, or comma m1 a1 equal 2 m1g minus 4t, or comma 4t equal 4 dot t, 4 times of tension, 4t equal 2 m1g minus m1a. Therefore t equal m1g divided by 2 minus m1a divided by 4, m1a divided by 4. This is the expression of tension acting in the string. T equal m1g by 2 minus m1a by 4. This is equation 1. Tension acting in the string. This is the tension acting in the string, which is equal to m1g by 2 minus m1a by 4. Tension acting in the string. Again, considering the motion of the body of mass m2 in horizontal direction towards the fixed pulley P2, we get again considering the motion of the body of mass m2 in horizontal direction towards the fixed pulley P2, in horizontal direction, we get m2a2 equal t, because the body of mass m2 will be moving towards the fixed pulley P2 with an acceleration a2 under the action of tension only. Now, for the body of mass m2, it will be moving with an acceleration a2 equal to a towards the fixed pulley P2 in horizontal direction under the action of the tension T acting in the string. Hence, m2 a2 equal t. Therefore, T equal m2a. This is equation 2, another expression of tension acting in the string in connection with the motion of the body of mass m2. This is equation 2. Comparing equation 1 and 2, comparing equation 1 and 2. One and 2, we get m1g by 2 minus m1a by 4. m1g by 2 divided by m1a by 4 is equal m2a, or comma two m1g minus m1a equal 4 m2a, or comma m1a plus 4 m2a is equal to mg, 2 m1g, or comma a equal 2 m1 divided by m1 plus 4 m2 bracket closed into g, 2 m1 divided by m1 plus 4 m2 bracket closed into g. That is the acceleration, of the body of mass m2. Therefore, a2 equal a, or comma a2 equal, therefore a2 equal 2 m1 divided by m1 plus 4 m2 bracket closed into g, 2 m1 divided by m1 plus 4 m2 bracket closed into g. a2 equal to m1 divided by m1 plus 4 m2 into g. So this is the acceleration of the body of mass m2, which is moving in horizontal direction towards the fixed pulley P2. Acceleration of the body of mass m2 moving in horizontal direction, towards the fixed pulley P2, If we draw the diagram again, this is the fixed pulley P2. A body of mass M2 is placed on a horizontal table. This is the body of mass M2, which is tied to one end of the string. String is passing over the fixed pulley, and this body of mass M2 is moving towards the fixed pulley with an acceleration A2 equal to A, which is equal to 2m1 divided by m1 plus 4m2 into g. So this is movable pulley to which another body of mass m1 is suspended. This movable pulley, from this movable pulley, another body of mass m1 is suspended. Now, what about a1? Acceleration of the body of mass m1 is a1 equal a by 2 equal 1 by 2 into 2m1 divided by m1 plus 4m2 bracket closed into g. 2m1 divided by m1 plus 4m2 bracket closed into g. Therefore, a1 equal m1 divided by m1 plus 4m2 bracket closed into g. Therefore, a1 equal m1 divided by m1 plus 4m2 into g. This is the acceleration of the body of mass m1 which is moving downwards. Acceleration of the body of mass m1. Acceleration of the body of mass m1 moving downwards. In the diagram, this is the body of mass m1 which is moving downwards with an acceleration a1 equal a by 2. a1 equal a by 2. And we get a1 as m1 divided by m1 plus m2, m1 plus 4m2 into